To weather systems. This is chapter 15 in the optional textbook if you have it. So before we start talking about weather, which we've already kind of alluded to weather a little bit when we're talking about rain forming and lifting mechanisms from the last lecture, but I want you to answer the following. So one, what are 3 examples of how weather affects your daily life? So why is it important for you to understand weather in the first place? And then I'm just curious what the most extreme weather event you've experienced is. So was it lots of rainfall that led to flooding? Was it a hurricane? Have you seen a tornado? Snowfall, ice storm? That's what I'm curious about. So what's the most extreme weather event that you've experienced? So if we define the weather, it's just the state of the atmosphere at any given time, any given location. So what is the temperature doing in Houston, Texas on a given day? What's the temperature doing in Maine on a given day? So at any given time and place, what's the temperature doing? And then what's the moisture doing? So is it raining? Is it snowing? Is it sleeting? Is it windy? Is it not windy? So the state of the atmosphere at any given time and place. So as you already know, or as you're already familiar with, depending on where you live in the US, it's going to affect what kind of weather and climate things you have to deal with. So this map here is showing us wherever you are in the US, what you have to worry about the most. And that would be wildfires if you're in the Western US. That would be droughts if you're in the Western US. If you're in Texas, you have tornadoes, you have flooding, you have hurricanes, severe weather. If you are in New England, for example, we have winter storms that we have to worry about and the occasional hurricane that we have to worry about. And then obviously, if you're down in Florida, for example, you would have hurricanes, you would have flooding and things like that to worry about. So it's a little bit morbid, but if we're looking at weather-related deaths, it depends on the region that we're looking at. So regional dependent, typically the southwestern US has the highest rate of weather-related deaths, and that's because they have drought and they have high extreme heat. So for example, Phoenix in the summer of 2023 had more than 30, a full month consecutive of days that did not go below 100 degrees even at night. So there are higher rates of heat illness and heat related deaths in the southwestern part of the US. So excessive heat tends to be the largest proportion of weather fatalities each year in terms of percent, but then also floods and tornadoes also have an impact. So just to remind you, because this is literally the crux of trying to understand weather and how weather works, this should look familiar to you, hopefully, that if you take a cube of air and you cool it down. By cooling it down, you squeeze it together, it becomes more dense. That makes it under high pressure, and it becomes sinking air. If you take that same cube, you heat it up, it becomes less dense, it's under lower pressure, and it becomes rising air because it is less dense. So if we look at wind first, so we're going to talk about a couple weather phenomenon. If we look at wind first, what I want to point out is that Mount Washington, which is in New Hampshire, so just north of here, is the highest peak in New England. It's at 6,277 feet, I think, above sea level. And it's notorious for having some of the worst wind speeds on Earth historically. They broke the record for the highest wind speed ever recorded, and it was like 234 miles an hour, or 230 miles an hour, I believe, back in 1934. It is so windy to the point where if you are out there in the winter and you're unprepared, you could get frostbite within a minute or so. That's how dangerous it is. So the wind chill can get down to negative 100 degrees. And then it's so windy up there that basically all the buildings that are on top of the summit, there's a weather station up there. They have to be changed down or otherwise the buildings would fly away. So here's a picture of one of the buildings on the summit and it's chained down to the ground. So if you want a video to watch in terms of looking at people trying to walk around on the summit in very, very high winds, I would suggest looking up a couple of videos of Mount Washington's wind. There's some silly ones on YouTube if you want to find some and see what the wind is like on the top of Mount Washington. So why do we have wind in the first place, and what is wind created by? So air pressure, if it's high or low pressure, pressure is not the same all across the globe due to differences in heating. So we know that on any given day, the sun is probably hitting the equator most directly, but if there's clouds out, some locations on our surface are going to be warmer than others because they're not blocked by clouds or they are blocked by clouds. So That creates differences in temperatures of air, and air does not like to be different temperatures. It wants to be equal, it wants to equilibrate. So, for example, what wind is the movement of air from a high pressure, which is typically labeled as H on these diagrams that we have that are used for forecasting. Air will blow from a high pressure towards a low pressure. And we can tell high versus low pressure just by looking at the numbers. So this is in millibars. But 1,020 is a higher number than 1,000. So the 1,000 is labeled as L for low pressure, warm, rising air. H for high pressure, cool, sinking air. And it's a high pressure because it's under that larger number, 1020. So I already said this, but you can predict which way wind will blow on a given day. If you know where high and low pressure is, high pressure in this diagram is over here in Utah. Low pressure is out on the Pacific Ocean, so wind blows from high towards low pressure. So the wind speed and the direction is also influenced by pressure. We already discussed the direction. It goes from high towards low. The pressure, if you have high pressure and low pressure in a very close distance, close together, that raises wind speed because you have a large differential between pressures in a small area. So if you look at maps, the blue lines here, they're called isobars, but basically it's just telling you lines of pressure. So again, H is for the highest numbers on here, which I see is 1025. And then L is for the lowest, which is 987 millibars. Wind blows from high towards low. So in this map here, I could tell that wind would be blowing from the center of the US in Kansas, in Nebraska and Oklahoma, north up to the Great Lakes area. What I also know from this map is that the closer that these lines are together, the faster the wind speed will be because you have differences in pressure over a short area. So fastest wind speeds on this particular day are going to be right over the Great Lakes. If these lines are pretty far apart, then that's a nice clear day with very little wind whatsoever. Just to illustrate that again, wind blows from high to low pressure, and the diagram here on the bottom would have a faster wind speed because the bars are closer together. So you have a bigger differential in pressure in a smaller zone or a smaller region. All right, so I've illustrated that for you. So slower on the top, faster on the bottom. So if we talk about wind, we can kind of separate wind and systems into high or low pressure, as I already showed you on the maps. Low pressure, just to remind you, is warm air and it is rising air. So a low pressure system is where you're taking air from the surface and it is rising up into the atmosphere, cooling off, condensing, and forming clouds and rain. So if you have a low pressure system that's passing through on a given day, you're going to have clouds and you're going to have rain. High pressure is the opposite. So high pressure is cooled, sinking air that is more dense. So it sinks from the upper atmosphere down to the surface. And because it's doing so, it doesn't really have any moisture. So if you have a high pressure day, these are like what bluebird days are if you're into skiing or winter sports. Low humidity, clear skies, blue skies, and dry conditions. All right, so just to kind of go through a couple more quiz questions here. So you have a link to a video, and then I want you to discuss the 2 reasons why Mount Washington is so windy based on that video. Then pause and come back when you're ready. And then you have 4 and 5 here. So question 4, does the image below here depict a low pressure or a high pressure system? And then 5 on the right here, does this image represent a day that would be low pressure or high pressure? More questions for you. So you got a map here now to be able to practice. You need to be able to interpret the numbers. So you got 1,012, you got 992. So you need to think about where you would have high and low pressure. And then based on that, you can answer these 4 questions. So which point on the map is at the center of a low pressure system? Where would you find rising air? At what point on the map? Which point on the map is at a center of high pressure? And then where would you find sinking air on this map? So we have a couple more concepts to go through here. This is air masses. So an air mass is basically a region where you have the same kind of heat level, so hot or cold, versus moisture level, so if it's dry or wet. So we're just looking at the US here, North America, and we're looking at what creates our weather systems or our weather patterns here. And the way that we get these different types of weather and weather patterns in the US, it depends on these things that we call air masses. So there's different air masses that are usually around similar locations, and we give them kind of like a lowercase letter and then an uppercase letter, depending on where this air mass comes from. It's typically uniform in temperature and pressure because it forms over the same area that is subjected to the same lighting conditions and temperature conditions normally. So the way this works, our lowercase letters are either M or C. That's the two options. M is marine, so something that forms over the ocean, and then C is continental, something that forms on land. So you'll notice in the map here we have an MP, MT, MP, MT. So that means marine something type of air. CT, CP, and CA means continental, and then another type of air. So if we go through the uppercase letters or the capital letters, A is Arctic, P is polar, T is tropical. So tropical forms closer to the equator, polar forms farther away from the equator, and then Arctic forms up in the Arctic. So if we put these together, you can make any combination of these. So a CT, continental, tropical, so it's warm, but it's probably dry because it formed over land. MT, marine, tropical, so it's moist because it formed over water, and it's warm because it's tropical. MP, marine, so it's moist. P is polar, so it's cold. So this is a cold, moist air mass. And then our last one here is continental polar. Continental is dry, polar is cold. So you get cold, dry air. In the US, most of our weather systems come from these clashes between like a CT, continental tropical, and an MP air, or you get a continental polar air and it will clash with this marine tropical air, and that's usually where our tornadoes come from, which we'll talk about in the next lecture. So these air masses don't stay put. They are constantly moving and they can either heat up or cool down over time. So I know this is probably messy looking to you, but basically this is showing you the polar vortex, if you've heard of that. In the winter, periodically, it will shift downward. That's continental polar air that will shift down into the US and then create certain weather systems in the US. So this air doesn't stay put. Air masses constantly move and shift around. Just to finish up here, we'll talk about frontal systems. So we have warm fronts and cold fronts. And now that we understand high and low pressure, we can talk about warm and cold fronts. So a front, if you have been outside on a summer day and then a storm comes in, you know that a front has moved in. You can see the clouds will change, the wind will change, the moisture will change. So a front is associated with either a change in temperature, moisture, precipitation, and wind, usually all of those in combination. So on any given day in the US, there's different types of fronts that are moving across. So in this particular hypothetical example, we have a warm front shown here, and then a cold front shown here. So let's talk about cold fronts first. So cold fronts form when we have clashes of the polar air and the tropical air. They clash right over the Midwest, and that's what creates a lot of our weather systems and our frontal systems. So a cold front is typically associated with a very kind of steep change in temperature and moisture in a very fairly short area. And you can tell that a cold front is coming. If you are interested in clouds, you can tell a cold front is coming because you can look at, first it'll be cumulus clouds, and then they'll grow larger and larger until you get a full-blown cumulonimbus cloud. And when that cumulonimbus cloud is formed, you know that it's about to rain. You know that a cold front is about to hit. Just to show you an animation of how a cold front moves across the landscape, it kind of moves like a wedge. So it's like a giant wedge that will move across the landscape. It will push warm air vertically up into the atmosphere. And as warm air pushes vertically up into the atmosphere, it's going to form clouds in severe weather systems. So I'll let just play through again so you can see the cloud forming mechanisms. So you get showers, thunderstorms, and severe weather when a front is moving through. Here's an example of a cold front moving through Florida. If you look at the temperatures in Florida as this plays through again, it starts out at roughly 80 degrees at the beginning of the day. Cold front moves in, and then it gets down to the 50s as that cold front has moved through, and it's associated with rainfall, and drops in temperature. Warm fronts are less severe. So a warm front is when you have cold air that is already in that location, and then now a front of warm air is coming in. So this one doesn't come in like a very sharp wall of cold air. This one goes up and over the cold air that's already there. So warm air goes up and over cold air. And you can tell if, again, you're good at looking at clouds, you can tell and predict how many days away a warm front is just by looking at clouds. So if you see cirrus clouds, for example, you're probably a day or so away from a warm front approaching. Then if you have cirrostratus, you're even closer, altostratus, and then nimbostratus, it might rain a little bit, but then you know it's going to be warm afterward. Just to show you another animation of what a warm front looks like. So you have cold air already in a location. This is your warm front. It goes in a triangular shape up and over the cold air. It'll rain a little bit, but then you have this nice warm front behind it and this nice pocket of warm air. All right, so this is a good summary slide just to show you the change or the difference between the two. So we have our cold front here on the left side. It's a much steeper angle, more like a wall, and that pushes up clouds like cumulonimbus clouds. So you get heavy rain, you get thunderstorms, you get tornadoes that are associated with cold fronts. But then it clears up, but it's colder. And then if you have a warm front, it's more of a triangular shape to it. You can have cirrus, altostratus, nimbostratus clouds, and it's warm, and it's clear, and it's dry. All right, so here is a table kind of summarizing the different types of frontal systems and then what will happen to things like pressure, wind, temperature, the types of clouds you'll see, and precipitation. So what you're going to do is that you need to use this table to answer your final questions on the quiz. So what are 5 conditions or features associated with cold fronts? You can get that from the table that I just showed you. Question 11, what are 5 conditions associated with warm fronts? And then list 2 features or conditions that are associated with both warm fronts and cold fronts. All right, and then that is it for this lecture. So only a few more to go.